Let's begin this problem by making a sketch of what's going on. So they tell me that the point -4, 3 is a point on the terminal side of an angle. So what's going to be important is to know what quadrant the point -4, 3 is in. I don't need to graph this any more accurately than that. I just need to know that the point -4, 3 would be somewhere here in quadrant 2. And so what I'm going to do is just put a point in quadrant 2, and I'm going to do two things. I'm going to connect it to the origin, and I'm going to connect it straight down to the x-axis, always to the x-axis, never to the y-axis. In order to make a right triangle. The theta in question then is the angle that's formed again between the x-axis. So theta is going to be down there. Theta is always with the x angle, or with the x-axis, never with the y-axis. And then, since I know where that point was located, I can use that to find two sides of this right triangle. I counted -4 in the x direction and +3 in the y direction. This problem from here is going to be very similar to what we've done before, so a lot of this will feel like review. In fact, the only new part to this problem, the only thing that we're kind of interested in, is the fact that sometimes my sine, cosine, or tangent could be negative. So what I'm going to do is find that missing side, the hypotenuse in this case, by doing the Pythagorean theorem. You'll notice I included parentheses around that negative number, so when I square it, my c value, or we'll eventually call it the radius of a circle, is always going to come out to be positive. And in fact, in this case, it's not even an integer, or it's not even an irrational number, it's an integer. So we just get 5 for that missing side, okay? From here, we're going to do the exact same thing we've done in the past. So I think what I'll do next is identify the names of my three sides. We already labeled the hypotenuse, where we identified it. The opposite side is going to be the 3 over here. And then the -4 is going to be my adjacent side. Again, this problem should feel very familiar to you other than the fact that we're going to have negatives in some of our ratios. Okay, so let's find the sine, cosine, and tangent by using SOHCAHTOA. The sine is the opposite side over the hypotenuse, so 3/5. And the cosecant is just the reciprocal of that, so 5/3. The cosine is the part of SOHCAHTOA, so adjacent over hypotenuse. That's going to be -4 over 5. So there's our first example of a cosine being negative. The secant's going to be the reciprocal of that. And even though it's the 4 that's negative in that first fraction, I like to just make it -5 over 4. It looks weird if it's 5 over -4, in my opinion. So either way, it stays a negative. And then finally, tangent is the opposite over the adjacent. So again, I'm going to leave the negative just in the top. So -3/4. And then the reciprocal of that for the cotangent would be -4/3. So the exact same thing we've done in the past, other than we have negatives now as answers. And then one quick thing to note down here, watch what happens when we do sine divided by cosine. Just an interesting thing to note for what's going to be coming up pretty soon. So my sine ratio was 3/5. So if I need to use a calculator, I can do that. But I want to take 3/5 and divide that by the cosine. That was -4/5. And if I do that on a calculator, if I'm not sure to do that by hand, it comes out I come out with an answer of -3/4, which turns out is the same thing as the tangent. And so this, what we just found out then was if I do sine divided by cosine, I find out what the tangent was. This will be, I don't know if you think it's interesting, but kind of an interesting thing for what's coming up.